I'm waiting. There's probably a little bit of a time lag on my side. I'm still seeing here we go. Good. As you heard from Joel this morning, he updated a little bit on the rover status. So I've got some more on that. And I don't know if many of you have seen me give talks remote before, but often I've had a cartoon or pretty graphic of the Viper rover in the background. But now I've got the actual real thing in the background here. So progress. We've completed integration last June. We finished vibration testing. I actually got a text about half an hour ago that acoustic testing is complete actually now. So Viper has completed its launch environments test campaign, and we'll do a baseline set of tests before heading into thermal vac. I'll point out that every single element within the rover has already gone through its element level thermal vac. So very low likelihood of significant issues as we move through thermal vac. So next slide, please. Just another pretty picture of the rover on the vibration testing. We completed this a week and a half ago or so. All systems checked out. That's why we were able to go straight into acoustic testing. Got in the facility this last weekend. And as I just mentioned, those tests have now completed. Next slide. Just a little show and tell. I had the great honor and privilege to actually be able to fasten one of 24 bolts that hold the wheels onto the rover. And don't worry, the certified techs came in immediately after and checked that that bolt was properly in place. I didn't actually do the final running torque or anything like that. But it was really cool being able to have that opportunity. And also it's a good slide in terms of giving you a sense of the size of the rover, the 50 centimeter wheel there compared to me. Next slide. And here is the flight article in front of the TVAC chamber. That's chamber 1 down at JSC that we plan to get into next. Next slide. Just, again, pretty pictures showing the readiness of the rover. But it's much more than the rover. We often focus just on the rover, but it's the operating of the rover, both from a ground data system and infrastructure point of view, but also the people and the operators who will be operating the rover and conducting the science. So the next several slides are on specifically that. This shows an image of the Mission Operations Center. It's one of 3 facilities that would be operating Viper. There's a payload operations center not shown here, and then a mission science center that I have a couple slides on next. The ground data systems, the flight software, the operations have been development from the project start. This was by design. We don't have, because we're going to the moon, we don't have the luxury that Mars programs often have, and having that extra 9 months to refine some of their operations and training. We had to be ready to go at launch. So it's really important for us to get an early start on this aspect of the mission. As part of it, we've developed this, in my opinion, beautiful high fidelity lunar environment model that includes the rover mechanics, the rover slip, everything like that. It's based on real lunar data down to 1 meter and then high resed up to 4 centimeter kind of resolution. And that's used to actually help train the entire team. And so that's been in place for at least a year now. And we've been training with it since as we develop and work on the ground data system, which is now pretty much complete. We have over 4,000 individual console training hours so far, with 700 hours of team training, so individual shifts and teams coming on. What you can see in the front row of this picture to the far left with the person there is me, actually, in the real-time science operator seat. We sit right next to the rover driver, which is to our right. And this just it exemplifies how integrated science is into this mission and the operations, that the rover driver is looking to the real-time scientists continuously to maximize and optimize science return. Next slide. We also have the Mission Science Center. I've got a couple slides on it. It also got started very early, and the intent here was to really make sure that science was integrated all the way through the mission development, which is usually the usual case, but we really want to emphasize that it was integrated through the operations. It's a real-time science operation that gave us opportunities to do things other missions haven't been able to do. We developed a operations plan that established this entire work system, and then worked closely with each of the other facilities within the mission systems team. That's a team that actually operates the rover, including the Mission Ops Center, the Payload Operations Command Center, as well as connections with Johnson and Kennedy that support the real-time operations carried out by Viper. And these science operations are used in missions for everything from traverse planning to real-time analysis. We actually will be making real-time prospectivity maps. Clive mentioned the need for these. Absolutely, we actually ingest data in real time in the Mission Science Center, and have working with USGS team members actually generate prospectivity maps that we use to do additional planning in real time. That was tested out just a couple weeks ago in an end-to-end test at Ames. This picture shows the collaboration room. It's just adjacent to our operations room in the Mission Science Center. This is where theme scientists, instrument science leads can come off their console for a moment and actually work collaboratively on decisions and discussions. The next slide. Thank you. Shows the actual Mission Science Center operations room. This is where we have science themes, instrument science themes, and a mission science center lead who's coordinating with the science lead and the real-time scientist, as well as flight in the mock that I showed earlier. And I've mostly said everything here. One of the most important roles for the MSC is it considers the observations in real time and allows us to actually make changes to the plan. Built into the plan was the intent to change the plan. And so the whole facility, the process, the procedures, the training all work towards that to optimize, for example, where we put our third drill site in each science station. Next slide. And also, you've probably seen me over the last few years saying this is a notional traverse, or this is an example of a traverse. Well, this is the traverse, recently completed. It is now going into what we have, what we call a traverse review board, which is a smaller subset of element stakeholders that review it, and then it will go to a Viper PCB by the end of this month, next month, by the end of August. And then the science team will collectively plan the science stations in this traverse. So next slide gives a few statistics on this traverse. I'm pretty excited about it. It's beautiful. You can see it actually visits 4 very different PSRs of different ages, different paleo and current, predicted ice stability regimes. The first PSR we go to on the far left there, it's a 1.7 kilometer wide crater, about 3.6 billion years old. It is predicted to have had surface ice stability both in the paleo environment per the Siegler et al. Predictions, and currently this traverse is about 34 total kilometers long. It does not have the final lunar day plan, so there would be an additional lunar day plan. That's open to a variety of discussions we want to have in terms of, well, what do we do with the rover when we're done with it? Do we drive it deep into a PSR, or do we actually strategically position it that maybe an Artemis lander could later take advantage of landing near it and using it as a test subject, if you will. It visits 24 science stations. And I will add, this is a much more conservative traverse too that we've done in the past. It includes much less assumed DSN coverage time. But you can see it has a nice balance of dry, deep, shallow, and PSR activities. We get about 1,700 meters of total prospecting in PSRs, and I think that would go up based on some new estimates. From a drilling point of view, we drill 3 times in each of the science stations, except for PSR where we drill once. But if you look at the statistics here, we're talking upwards of 45 to 50 1-meter drilling activities in this traverse. Next slide. And this brings me to make a comment on some of the things that have been said about making up for Viper science. I really greatly appreciate some of the community members stepping in and questioning that statement and assumption. I made this chart and I had it vetted by some others in the community, so it's not just my opinion here, about how Viper compares to other payload missions. The most critical differences is that Viper was designed to drive far, last long in a PSR, 9 hours in each dip, and drill often. Static drilling activities will never even come close, in my opinion, to making up for what Viper can do. And actually, if you're interested in why that is exactly, happy to provide the measurement plan for Viper that details that. Next slide, which I think is my final. So what's the future for Viper? As we heard, its intent is to, NASA's intent is to terminate. We have to wait for Congress to approve that. I will point out that the assuming October 2025 mission start, that 84 million that has been talked about, that includes both funded schedule reserve and cost reserves, or UFE. So there's already reserves that have been taken into account for unknowns that might occur in testing. That I will also add that cost number was independently verified by an outside entity. If the launch goes beyond 2025, there's no reason why you would think that each year would be that pricey. We could easily store the rover and bathtub the team to a critical number of people for a fraction of that cost to go, and those numbers can be provided. As you heard, they if it is indeed approved by Congress to cancel Viper, they'll disassemble, remove the instruments, and so we'll see how that goes. I expect the cost to do that will be, the majority of the 84 million to just fly it. That's my personal opinion. But I will really definitely highlight what was pointed out, that they are seeking expressions of interest. I know I've received many already, very serious ones. So if you're out there and you are interested in flying Viper, participating with others in flying Viper, reach out to us and we can discuss that.
Thank you so
Last
much.
slide is just a thank you to everybody who has supported Viper over the years, especially the league, who has championed this concept for a decade. Thank you.